Hey everybody, my name is Scott, and today we're going to solve the binary watch problem on LeetCode. The problem definition is a binary watch has 4 LEDs on the top representing the hours, 0 through 11, and 6 on the bottom representing the minutes, 0 to 59. Each LED represents a 0 or a 1, least significant bit on the right. We're given a non-negative integer n, which represents the number of LEDs on. Return all possible times that the watch could represent. So here for n equals 1, that means there could be 1 hour, no minutes, 2 hours, no minutes, 4 hours, 8 hours, 1 minute, 2 minutes, 4 minutes, 8 minutes, 16 minutes, 32 minutes. Alright, so it's a pretty confusing problem definition, but the implementation is really easy. All that we're going to do is loop through each possible combination of hour and minute and check the bit count. And if the bit count sums up to the number of bits that are on, then we will add that time to our list. So we've got an array list, which is going to store the times that we're going to return. And we just got a loop. Start hour at 0. We're going to loop up to 11. And then we're going to have a minute loop on the inside here. Starts at 0 as well. Goes up to 59. And what are we going to do? We're going to check the bit count, the sum of the bit counts of the hour and the minute. And see if that's equal to the number of bits that are on the watch. If it is, then we just have to add that time in. Little check here, if the minute is less than 10, then we need to add a 0 in, a leading 0. And all we're doing here is just constructing the string. Alright. Assuming no typos, that should do it. Zero looks pretty good. Let's give it a more interesting test case. Let's see how that looks. Alright, looks good. And it's an accepted solution. Cool. So all we did was we're given the number of bits that are currently on the watch. So we have a times list that keeps track of all the times that it could be. And then we just loop in. What we're doing in each of these loops is we're checking each combination of hours from 0 to 11 and minutes from 0 to 59. We check the bit count, the sum of the bit count of the current hour and the current minute, and if it's equal to the number that's on the watch, then this is a possible time that's being represented by the watch. And then we just construct the time. We take the hour, throw a colon in there. If the minute's less than 10, we need a leading 0. Add the minute in there, and then just add the time. That's all for this one. Pretty straightforward problem, and we'll see you next time.